Hi, and welcome to this review of linear equation forms. Specifically, we'll be talking about slope-intercept and point-slope forms. We will also review the terminology and the process of graphing linear equations in these forms. Let's get started. A linear equation can be expressed in many different ways, but no matter which form you use, it just represents a straight line. The standard form of a linear equation is written as ax plus by equals c, where a, b, and c are constants, and x and y represent variables. This form of the equation is very useful for some purposes in math. For example, a line can be quickly graphed when it is in this form by finding the x and y intercepts. There are also methods of solving systems of equations that require each equation in the system to be written in this form. Rearranging the standard form equation into slope-intercept form, y equals mx plus b, reveals other key features of the line, namely the slope and the y-intercept. The slope of a line describes the slant, or steepness, and the y-intercept is the point on the graph where the line crosses the y-axis. Notationally, slope is represented by m, and the y-intercept is represented by b. Because the y-intercept is an actual point on the coordinate plane, it is represented as an ordered pair, 0b. Sometimes you will be asked to rearrange an equation from one form to another. Here's an example. 2x plus 3y equals 12. Remember, the standard form of a linear equation is ax plus by equals c, so this is currently in standard form. If we want to change it to slope-intercept form, we are going to need to rearrange it so that y is by itself on our left side. Our first step is to subtract 2x from both sides. 3y equals 12 minus 2x is what we have now. Then we're going to divide everything by 3, which gives us y equals 4 minus 2/3 x. This is almost right, but if we look again at slope-intercept form, we see that we need the x term to be in front. Thankfully, we can think of this as 4 plus negative 2/3 x and use the commutative property of addition to swap their places. This gives us y equals negative 2/3 x plus 4. The resulting equation is more informative about the line than the original equation in standard form. The coefficient of x, negative 2/3, is the slope. A negative slope tells us that the line slants downward from left to right. The y-intercept of 4 tells us that the line crosses the y-axis at the point 0, 4. Now that we have seen how to convert a standard form equation into slope-intercept form, let's practice recognizing the key features of slope and the y-intercept with a few examples. For these examples, we want to name the slope, describe the slant of the line, and name the y-intercept as an ordered pair. Y equals 2x plus 3. The slope of this equation is m equals 2, the coefficient of the x variable. A positive slope indicates that the line slants upward from left to right. The y-intercept is b equals 3, which indicates that the line crosses the y-axis at the point 0, 3. Let's try another one. Y equals 3/5 x minus 2/3. The slope of this equation is m equals 3/5. Because the slope is positive, the line slants upward from left to right. The y-intercept is negative 2/3, which indicates that the line crosses the y-axis at the point 0, negative 2/3. Let's try one more. Y equals negative 5x minus 2. The slope is m equals negative 5. Negative slope means that the line slants downward from left to right. The line crosses the y-axis at the point 0, negative 2. As you can imagine, knowing where the line crosses the y-axis and the slope of the line will make the line very easy to graph. Now let's take a look at how slope provides you with instructions to graph from the y-intercept. Any value of slope can be looked at as a fraction, where the numerator indicates where to move along the y-axis and the denominator indicates where to move along the x-axis. Movement along the y-axis is typically referred to as the rise. A positive rise value would instruct a move up the y-axis, while a negative rise would indicate a move down the y-axis. Likewise, a positive run value would mean a shift to the right, and a negative run would mean a shift to the left. Here are a few examples to practice identifying the rise and run indicated by a given slope. M equals 5. This slope is not written as a fraction, but any whole number can be rewritten as a fraction over 1. M equals 5 over 1. The numerator, 5, is the rise. The positive value means up 5. The denominator is the run. Positive value means right 1. Let's try another one. M equals negative 2/3. When you have a negative slope, you can consider either the numerator or the denominator to be negative, not both. For this example, let's consider the numerator, the rise, to be the negative value. Negative value means down 2. The denominator, 3, is the run. Positive value means right 3. Here's one last example. M equals negative 3. First, we need to rewrite the whole number as a fraction, negative 3 over 1. Let the numerator be the negative value. Rise is negative 3, down 3. Run is 1, right 1. Now on to some graphing. People sometimes find it helpful to use the notation of slope-intercept form to get started. Begin at B and move according to M. Let's graph the linear equation in slope-intercept form. Y equals 2/3 x minus 2. Step 1. Begin at B. Plot the y-intercept 0, negative 2, first point. Step 2. Move by M equals 2/3. Rise equals up 2. Run equals right 3. Plot the second point at 3, 0. Step 3. Repeat the rise equals up 2 and run equals right 3. Plot the third point at 6, 2. Step 4. Draw a straight line through the 3 points. Got the hang of it? Let's try one more. Y equals negative 2x minus 3. Step 1. Begin at B. Plot the y-intercept 0, negative 3, first point. Step 2. Move by M equals negative 2 over 1. Let the rise be negative. Rise equals down 2. Run equals right 1. Plot the second point at 1, negative 5. Step 3. Repeat the rise equals down 2 and run equals right 1. Plot the third point at 2, negative 7. Step 4. Draw a straight line through the 3 points. Note the slant downward from left to right due to the negative slope in this equation. Now that we have had some review of the key features of linear equations, we have the tools to explore the point-slope form. This form is of special use if we know one point that is on the line and the slope. The general form of this arrangement is y minus y1 equals m times x minus x1, where m equals the slope and x1, y1 is another point that is known on the line. Using this template, let's practice identifying the slope and the point from the following examples of point-slope form. Y minus 5 equals 3 times x minus 2. This is a straightforward example. First, identify the slope as the coefficient outside the parentheses, m equals 3. When naming the point on the line, note that in the general form, the x-coordinate is being subtracted from x, and the y-coordinate is being subtracted from y. So the ordered pair of the point will be 2, 5. Here's another one. Y plus 3 equals negative 1/2 times x minus 4. The slope in this equation is m equals negative 1/2. How is this equation different from the general form y minus y1 equals m times x minus x1? You may have noticed that the y value of the point 3 is being added. To identify the point that is on this line, the equation must look like the general form, which subtracts the coordinates of the point. Therefore, the point can be seen more clearly if the equation is written as y minus negative 3 equals negative 1/2 times x minus 4. Subtracting a negative value is the same as addition. Now we can see that this line travels through the point 4, negative 3 and has a slope of m equals negative 1/2. Let's look at one more example. Y plus 12 equals negative 3 times x plus 5. By now, you can quickly see that the slope of this equation is m equals negative 3. This equation also does not match the general form, but it can be rewritten as follows. Y minus negative 12 equals negative 3 times x minus negative 5. This adjustment reveals that the point that is on the line is negative 5, negative 12. Once you feel comfortable with identifying the slope and the point from this form, you can graph the line as we did before. Y minus 5 equals 1/2 times x minus 2. Step 1. Identify the slope m equals 1/2. Step 2. Identify the point on the line 2, 5. Some students find it helpful to switch the sign of the given formula to determine the coordinates of the point. Step 3. Plot the point 2, 5 as the first point. Step 4. Move by m equals 1/2. Rise equals up 1. Run equals right 2. Plot the second point at 4, 6. Step 5. Repeat the rise equals up 1 and run equals right 2. Plot the third point at 6, 7. Step 6. Draw a straight line through the 3 points. Alright, we've covered a lot of ground in this video regarding the different ways linear equations can be written. While the structure of the equations looks different, they all represent a line. The use of each depends on what you are given or what you are asked to do. That's all for this review. Thanks for watching and happy studying.